Okay, hello, what is going on, everybody? Let's go to chapter 4. This is called Heat, where this is a chapter where some of my friends actually need help. First thing first, you need to understand the definition of heat. Definition of heat is actually defined as the energy transferred. Energy transferred from a hot to a cold substance. Remember two parts of this definition. Firstly, is energy transferred from a cold to a hot substance. Okay, with these two sentences, I think it's not that hard to remember, right? So, what is it? Heat is energy transferred from a hot to a cold substance. Please do not say heat is a form of energy that is like Form 1, Form 2, Form 3, lower secondary, okay? So, heat is energy transferred from a hot to a cold substance. So, next term that you need to understand, this is called thermal equilibrium. This thermal equilibrium things is sort of cute. So it is basically defined as when the rate of heat transfer is basically the same. So let's say I have two objects right here. You can put your hand on your monitor screen right now. Do it right now. So I have my hand touching the monitor screen, and then I touch it for a short while. And tada, suddenly the heat from your hand is transferring to the monitor. The heat from the monitor is transferring to your hand. So when these two hit, they kind of transfer and transfer and transfer until certain point. Suddenly you realize the temperature of your hand and the thermometer of the monitor is the same. Then you realize that the heat actually transfer at the same rate. Now the heat is still transferring, just that they are going out of your hand and going in of your hand at the same rate as the monitor's heat going out and in. Yep, that is called thermal equilibrium. In another term, this is a simpler term to remember. It is actually called net heat flow is equal to 0. Okay, let's kind of write that down. Net heat flow is equal to 0. This means, using the same concept just now, that both of the hand and the monitor, they both didn't gain much heat energy. The monitor doesn't gain any heat energy at all. They are like at the same rate of transfer. Now, I think we need to apply this to a more practical term, shouldn't we? Okay, let's say I have a cup. Inside there there's ice cube. So I put in the ice cube. You see the ice cube starts melting because the heat starts to go into the ice cube. And when the heat goes inside of an ice cube, what does it happen? The temperature of ice cube raises and it starts melting. So practically when all the ice has turned into water, then they become thermal equilibrium. This is when they are kind of sharing the same amount of heat with the drinks that we have and the ice water molecules that are sharing the same amount of heat. That's when we say they reach thermal equilibrium. They have net heat flow equal 0. Next cute little term here, we call it thermal contact. Thermal contact is actually a contact. Let's put it in this way. An object is in thermal contact. So basically, remember, an object is in thermal contact when the heat can flow. So basically, if I'm touching you from don't know how many miles here, if you are touching another person, you can see the heat are actually flowing between both of your body parts. That is called heat flow. If your hand is touching the monitor and that your monitor is a little bit warmer, then you can know that there's heat flow. So let's say your hand is touching the ice. This is a wonderful hand. It's touching the ice. That your heat from your hand is going inside the ice. We call this in thermal contact. So basically, every physical things that comes into contact, we can say that they are in thermal contact. Okay. So yep, this is the term in thermal contact. There we go. End of story.